Okay, fine. So as today we are going to discuss about the Naviwire part 2, assuming you have successfully completed Naviwire part 1. Okay. So as part of today's agenda, this is the things that I have said that we will discuss. So a quick revision, recap, whatever we have discussed in the last class. In the sense, basically, I will give a quick recap about the Naviwire part 1. Okay. Then we'll see Bayesian probability distribution, tossing coin and rolling dice example, another rule of probability we'll see, then Bayes theorem we'll see. Then I will try to solve different kind of use cases like taxi use cases, purchase no purchase use cases, probability of spam provided no purchase. Okay. Then LinkedIn job and no job use cases, e-commerce website ad use cases. Then I will try to cover a color blind use cases. Almost a lot of use cases. How many use cases can you tell me? Starting from here, another taxi use case. Yeah, starting from here up to this one. Almost children example also. Then we'll try to cover the quick introduction to Bernoulli Naive Bayes. What is the different key characteristics? Formula of Bernoulli Naive Bayes. Example use cases, that is spam detection, key takeaway. Okay. Then we'll discuss about Bernoulli Naive Bayes versus multinomial Naive Bayes. Then example scenario. Then we'll see which one we should use at what time. Okay. So we'll discuss everything as part of today's agenda. Let's first now start with the first one. That is a quick recap of the revision of the Navi Bats Part 1. Okay. So what we have discussed, obviously we have not discussed in your class, but let me show you the handwritten notes that I have discussed in my previous classes. This is part of Naviverse Part 1. Okay. So as part of Naviverse Part 1, I have also discussed different type of use cases like next word use cases, Swiggy Zomato use cases, Cappuccino Espresso use cases, spam not spam email use cases, positive digit use cases, then Amazon ad use cases, LinkedIn Twitter use cases, then Bayes theorem, what is cricket match use cases, what is the difference between a probability and a conditional probability. Okay, then these are the things. Then one funny incident happens. For example, you went to interview without studying Bayes theorem. Then what will happens with you? Okay, Nabi Bayes with one feature, two feature, and multiple feature comprehension, relational independent in Nabi Bayes, then dispersing, and Nabi Bayes. So these are the things. Obviously, we have discussed as part of your classes also. Previous classes, like what are the confusion matrix we have covered, and different parameter like precision, recall, F1 score, accuracy, sensitivity, specificity, TPR, APR. These are the things we have already covered, right? Then ROC, AOC core, ROC core, ROC AOC score, perfect model versus random model. Then conditional probability, how we are solving the conditional probability by taking the help of Bayes theorem and all. So these are the use cases that I cover as part of my different batch. Obviously, as I told you, as time permits, then obviously May 1st, I'm going to cover this part 1 also once again. Okay, don't do it. So just have a quick look. So this is the Bayes theorem, how I'm solving. Obviously, in today's class also, I'm going to solve a lot of use cases by following the same methodology. The formula of Bayes theorem. Okay, so these are the things we have covered as part of the previous classes. So let's come back to our today's agenda. So that was a quick introduction, quick revision. Okay. So as I told you, like Nabe Bayes, in short, let me write Nabe Bayes. Okay, let's say part 1. If May 1st will be not holiday, then definitely we'll cover on May 1st. Okay. Because similar stuff like I'm also going to cover in today's class. Okay. So even though it is a holiday, nothing to be worried because anyhow you have some idea about what is Navibars and all as the other faculty they have started in the last classes. Today I'm going to enter little bit in depth. Okay, by solving different type of problem statement or use cases. Fine. So let's start with the second one, that is Bayesian probability definition. Let me mark, tick mark what are the things that we have covered. Probability definition. Fine. Okay. So let me. An alternative is Bayesian theorem, that is which defines probability as a degree of belief that an event will occur. By this definition, the notation of probability can be applied in almost any circumstances. One difficulty with the Bayesian probability is that it depends on a person's state of knowledge. People with different information might have different degrees of belief about the same event. For this reason, many people think that Bayesian probability are more subjective than frequency no probability. So what is that? Obviously we'll see little bit going ahead. Think about, I'm taking the example of two-person. For example, in past cases, if A is tossing a coin and getting head, and B, which is another person, is rolling a dice and getting one. Now I can say A and B are independent event. Why? Because there are two different activities going on. One person is tossing the coin, another person is rolling the dice. So there is no relationship between them because the coin tossing does not tell me anything about the die roll. Okay, but if I will tell second scenario, if I'll tell I roll the dice two times. A is getting at least one six, and B is getting two six. Then A and B are not independent because I know if I know that A occur, the probability of B is higher, and if I know B occur, the probability of A is one. When A and B are not independent, it is often useful to compute the conditional probability, that is P, probability of A given B. So this pipeline symbol, right, we generally read it as probability of A provided B or given B. Which is the probability of A given that we know B is occur. So what is the normal formula? Probability of A given B is equal to probability of A and B divided by probability of B. And from that, we can derive the general equation that probability of A and B is nothing but probability of A into probability of B given A. Okay. Now, if I will compare both the equation, then I can derive a someone new equation. Let me come back to my whiteboard. I will explain by taking the help of my whiteboard. Okay. Yeah. I will do. So here, guys, I'm taking two different scenarios. Scenario one, scenario two. What is happening here is telling, for example, think about there is two person. One is person A, another one is person B. Here what happens? A is tossing a coin. Whenever A is tossing a coin, either obviously head will come or tail will come. But it's telling head is coming. Okay, fantastic. Now B is rolling the dice. You know that Ludo or that indoor game, right? If is rolling the dice basically, the probability of getting either 1 or 2 or 3, 4, 5, or here C may get 6 also. It's telling that he or she is getting 1. Okay, fantastic. This is the one scenario. Now here in the second scenario, I'm taking same person A and B. But here both are playing the same game, that is throwing the dice two times. Two times. Out of two times is telling one time definitely A will get 6. Other time, another time, obviously A may get 1 or 2 or 3 or 4 or 5 or maybe 6, right? Out of these 6 different outcomes, any one outcome may come. So the combination will be either, for A it will be either 6 comma 1 or 6 comma 2 or a 6 comma 3 or 6 comma 4 or 6 comma 5 or 6 comma 6. Yes or no? But here B is telling both the time, two times is getting 6 and 6. That is no other option. Getting my point, guys? So generally what happens, as here in scenario 1, both are playing two different activity. One is tossing the coin, another one is throwing the rolling the dice. So I can say A and B are independent event, means there is no relationship between them, because this is one game, this is another game. Think about this, this is a playing cricket and playing football. Okay, so this is A and B. But here, guys, what happens? As both are playing the same game, those are not independent with each other, they are dependent with each other. Let's say this is A, this is B. Now, let's say this is a common C, a common area, that is 6. Why? Because A also getting 1 time 6, B is also getting at least 1 time 6. Now, there is another chance that B will get another 6. Why? Because this is compulsory. 2 times B is getting 6. But here for A it may be 1 or maybe 2, maybe 3, maybe 4, maybe 5 or maybe 6 also. So out of these combination, any one will pick, and obviously one time will be 6. But for B it is obviously 2 times will get 6. Why 2 times? Because I am throwing the or rolling the dice 2 times. Okay, rolling the dice 2 times. Clear? That's what it is telling. Okay. If both are independent, so obviously if independent, for example, I will tell, if A and B are independent, then what is the common part? What is the A intersection B? Obviously this is phi. Phi notation is this one, right, in the mathematics. So phi is nothing but null value, means there is no, or empty value, there is no common element between A and B, because both are independent with each other. But whenever in the scenario 2, I am talking about is dependent. So let me write out this is independent and this is dependent. Okay. So let me. Fine. Now this is independent and this is dependent. Whenever A and B both are dependent, in this case, guys, I cannot say, let me put it in a box. A and B are pi. I cannot say. Okay, let me use same color. A intersection B not equal to phi. Phi, or you can say, what is that? Empty. Null or empty, whatever you call, null or empty. Because A and intersection B, definitely some element are there. Clear? If this is the case generally, and you might have seen different type of equation in mathematics, like for example, I will tell what is the probability of A union B. It will be probability of A plus probability of B minus probability of A intersection B. Let's say this is 1. Now, tell me, in case of scenario 1, as A intersection B is equal to phi, so it will be kind of 0, right? So now probability of A union B is equal to probability of A plus probability of B. That's all, only. But in case of second scenario, guys, what will happen? Scenario 2, as this is not a phi, so this formula remain exist. Clear? Now, another one is, second one. We know this is probability of A union B, right? Similarly, probability of A intersection B, the formula is probability of A, first one, probability of A multiply with probability of a B given A. This is the second formula. Okay, these are the existing formula from the mathematics I'm deriving. Okay, now from scenario 2, as both are dependent with each other. According to this, I can say there is another formula exists. That formula is probability of A given B is equal to probability of A intersection B divided by probability of B. Probability of B. Clear, guys? Now, let me give some equation number. For example, this is equation 1. This is not required, this is existing one. Let's say this is equation 1. Now, this is according to the scenario 2. This formula exists for scenario 2. Now, let me simplify this equation. Okay. If I simplify this equation, can I write probability of A intersection B here? Probability of A intersection B is equal to, think about it, if I am trying to write here, then this denominator will multiply with here or not. Now it will be probability of B multiply with probability of A given B. Yes or no? Now let me give, this is equation number 2. Guys, are you able to understand? These are the existing equation. Okay, so I'm not playing with this one. Now, guys, try to compare the equation 1 and equation 2. In the left hand side, both are same. Probability of A intersection B, this is probability of A intersection B. If both are same, then can I say right hand side is same? Like I have to compare. So I can write from equation 1 and equation 2. Can I write? Just tell me what I can write. Probability of A multiply with probability of B given A. This one I am writing is equal to this part. Probability of B multiply with probability of A given B. Clear, guys? Any doubt so far? Any doubt so far? So let me put into the box. Clear, guys? Any doubt so far? Now, this is the, let's say, equation number 3. Now, there's another concept common in the picture, that's a mutual exclusion. Mutual exclusive. What is mutual exclusive? I will explain. Just hold your excitement. Mutual exclusive means the scenario number 1. Both are independent with each other. There is no common term between them. If there is common area between them, that is called non-mutual exclusive. This is not mutual exclusive. If it is a mutual exclusive, means there is no common area between them. A intersection B is equal to phi. Then in case of mutual exclusive, right? Then probability of B given A is equal to probability of A given B. Generally, that value is 0. Okay, now I'm trying to put this value in equation number 3. Now, from equation 3, if I'm putting the value, can I write probability of A is equal to probability of B in case of mutual exclusive? Guys, you can tell, sir, if I put 0, sir, if I put 0, then 0 into something will be 0, right? So 0 is equal to 0. There is no meaning. That's why I'm not putting the value 0. What I'm putting this value, like probability of B given A is equal to probability of A given B. Means this value, let's say for example, this value is 10, obviously this value will be 10. So if I multiply both the side 10, means 10, 10 cancel out. There can I tell probability of A is nothing but probability of B. Are you getting my point? So that's what I'm writing. That is, let's say, equation number 4. Clear, guys? Any doubt so far? Any doubt so far? If not, let me go back to my PPT. Yeah, you can see. So I was telling this is the formula and we know this one. So from this, can I derive this one? Probability of A and B is equal to probability of B into probability of A given B. Another rule of probability, that is, if two events are mutual exclusive, then in that case, that means that only one of them can happen, so the conditional probability will be 0. So probability of A given B is equal to probability of B given A is equal to 0. Getting my point? So if I put that in the equation, the previous equation I written, the first one, probability of A or B means probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now I can say probability of A or B is equal to probability of A plus B. Why? A intersection B is equal to phi in case of mutual exclusive. There is no common element between them. Correct? Clear? Now what is mutual exclusive? Let me. I hope you are able to see this diagram. Mutual exclusive. Clear? You can see. Both are independent to each other. So this is called mutual exclusive. If there is common area between them, that means dependent, not independent. That means non-mutual exclusive. So I'm talking about this mutual exclusive. In this case, A intersection B is equal to phi. Why? Because there is no common element between them. But in this case, A intersection B is not phi because there is certain common element between them. Clear, guys? This is mutual exclusive. This is non-mutual exclusive. Okay. Now, Bayes theorem. Guys, Bayes theorem is a relationship between the conditional probability of two events. A conditional probability of for often written probability of A given B is the probability of that event A will occur given that we know that event B has already occurred. Now the formula of probability of A given B is equal to probability of B given A into probability of A divided by probability of B. And you can see these are the different notation that we are deriving. To see probability of A and B means A intersection B is equal to probability of A into probability of B given probability of A union B is equal to probability of B and this one and this thing we have already written. So we have derived this, right? Probability of B into probability of A given B is equal to probability of A into probability of B given A. So this is the Bayes theorem. So from where you should derive it, you know, right? So from here is the yeah, clear? From let me repeat one more time. From equation 3 is written probability of A into probability of B given A is equal to probability of B into probability of A given B. What I'm doing, I'm keeping probability of B given A in the left hand side, and I'm taking probability of A into right hand side. So obviously, it will go to denominator probability of A, and the right hand side as it is, I'm keeping probability of B into probability of A given B. So this is nothing but my Bayes theorem. Bayes, Bayes theorem, or Bayes formula or theorem, or I can say formula. That's what is written in that PPT. So that I am derived in front of you only by using the mathematical equation. There is nothing greater. So this is called Bayes theorem. Or in a reverse way also you can write. I mean, if this is the case, can I write? Someone will tell, sir, can I write or this is wrong? Obviously correct. A given B, means this part is equal to, this will multiply here. Can I write probability of A into probability of B given A divided by probability of B? Can I write same or not, guys? Just I'm finding this one. Probability of A given B is equal to, I multiply with this one. Probability of A into probability of B given B, and obviously this is numerator coming to denominator, probability of B. So this is also Bayes theorem, right? So you write in whatever the notation or format, both are the same. This is also Bayes theorem. Okay, this is also Bayes theorem. Only difference is here you are getting probability of B given A, here you are getting probability of A given B. Accordingly, you just notation is changing, but both are the same. Clear? Any doubt so far? Any doubt so far? Now let's come back to my PPT. Now here, instead of A and B, guys, I'm just taking two different other notation, H and E. What is H? H is nothing but probability of hypothesis. E is nothing but evidence. According to Bayes' theorem, is often interpreted as a statement about how a body of evidence E affect the probability of a hypothesis, that is H. In words, this equation says that the probability of H after you have seen E is the product of probability of H, which is the probability of H before you saw the evidence, and the ratio of probability of E given H, the probability of seeing the evidence assuming that H is true, and probability of E, the probability of seeing the evidence under any circumstances H true or not. This way of reading Bayes' theorem is called the diachronic interpretation, because to describe how the probability of a hypothesis gets updated over time, usually in light of new evidence. In this context, probability of H is called the prior probability, and probability of H given E is called the posterior probability, and probability of E given H is the likelihood of the evidence, and probability of E is the normalizing constant altogether. Okay, now we are trying to, now we'll enter into a business use case, a problem statement. Okay, just try to read the question. Obviously I'll go back to my whiteboard, and obviously I'll write there and explain there. Okay, just try to read the question. Basically, this question is all about the taxi services that are provided to company are provided in a particular city. For example, think about, let's say, Uber and Ola. Okay, so here I've taken some unknown company, let's say company A and company B. You think about Ola and Uber. Company A has 60% of the taxi in the city, while company B has 40%. Company A taxi has involved in accident 3% of the time, while company B taxi are involved in an accident 6% of the time. If a taxi is involved in an accident, what is the probability that it belongs to company B? So these all are, guys, conditional probability statement or problem statement. I don't know who has taken your classes. That's why I told you. Obviously, I will go in depth in today's class. In time permits, obviously, May fast. I will cover rest of the things. Okay. Now, guys, whenever you're looking into the problem statements, now looks very easy, bit complex. Okay. From today's class, you have to learn. My request is one thing. You have to learn only one thing from me. The act of designing or drawing the diagram, this diagram from the problem statement as is written in the textual format. If you will learn this act from me, you no need to solve thousands of problem statements. Tomorrow, if someone will give a new problem statement, happily you can solve. If you are not focusing on that, you are not learning that thing from me, you are just focusing, okay, sir, how is calculating, what are the formula is using, then it will be a nightmare journey. Even though you will solve thousand problem statement on conditional probability, you cannot solve if you get a new problem statement altogether. Okay. So my humble request, please give your 100% attention and try to observe how I am deriving the diagram, how I am drawing the diagram out of a problem statement. Okay. Now let's come back to our whiteboard. We have covered. Scroll off. Yeah. So we have successfully covered tossing coin, rolling dice, another rule, Bayes theorem. Now we are in the sixth taxi use cases. Okay, taxi use cases. Okay, I'm just writing the question once again in the whiteboard so that it will be in front of your eyes and you can help me whenever I'm asking any question. What is telling, guys? There are two different company. One is company A. Another one is called company B. I'm just writing all the gist. It's telling 60% of the taxi belongs to company A. Fine. And obviously, rest of the things means obviously 40% of the company taxi belongs to company B. Correct. Now, out of 60 percentage, according to the question, is telling what is telling company A taxi are involved in accident 3 percentage time. So, out of 60 percentage, I can say 3 percentage time it face an accident. Accident. And here, I think 10 percentage. Let me cross check question once. 6 percentage of the time, company B. Okay. 6 percentage of the time, company B face an accident. Now tell me, if 3 percentage face accident, then how many percentage of taxi does not face accident? I can say out of this 97 percentage. 100 minus 3, 97 percentage, no accident. Clear? Similarly, here, if 6 percentage face an accident, then can I say 94 percentage face no accident? Clear or not? This is given in the problem and question. Now, what is my problem statement? Let me take some water. Yeah. It's given when taxi is involved in an accident, what is the probability that it belongs to company B? Means a taxi I choose will face an accident. But it's telling what is the probability that it belongs to company B? There is a question mark. Obviously, this is accident area. But that taxi should be belongs to company B, not company A. Now let's try to see how I'm deriving the diagram out of this problem statement. That is the act. That is one of the things that you have to learn from today's class. Then you'll be master, champion in the constant probability or Bayes theorem. Okay, now it's telling there are two companies there, company A and B. Company, so 60% of the taxi, entire taxi is belongs to company A, and obviously 40% of the company taxi belongs to company B. So for simplicity, let me take the entire taxi number is 1000. Okay, because whenever I'm calculating percentage, either I have to take out of 100 or 1000 or 10,000, something like that, some round figure. Okay, so let me take 1000 is the total number of taxi. So out of 1000, guys, help me. how many taxi belongs to company A? 60%. 60% means how much? Out of 1000, 60% means 600 taxi belongs to company A, and obviously 1000 minus 600, that is 400 taxi, which is nothing but 40% taxi belongs to company B. Yes or no? This is company A. Let me write company A. Try to learn step by step, guys. I am going. This is very very important. Company B. Clear? Any doubts so far? Any doubts so far? So this is the percentage given: 60%, 40%. Okay. Now I'll go to the next step, next extension process. Guys telling 3% face an accident. 3% of what? 3% of the 600 face an accident. Now tell me, 3% of 600 means how much it will come? Can I write 18? 18 number of taxi face an accident. Now tell me, out of 18 taxi are facing accident, then 600 minus 18. That is how much? 600 means 582, right? 582 number of taxi. He said no accident. No accident. Clear, guys. See how I'm derived. Try to observe. That is very very important. Step by step I'm going. Because 3% is facing accident. 3% of 600. How much? Just calculate. Use your calculator. You'll get to know. So 1% is 6. 2% is 12. 3% is 18. If 18 number of taxi face accident, then how many face taxi face no accident? Then 600 minus 18. That is 582. Correct. Now coming to company B. Company B is this one. This part. Company B. When talking about company B, you should not think about this area. You have to think about this second part. Okay. 6% is face an accident. Now 6% of what? 6% of 400 face an accident. Okay. Now tell me, 6% of 400. How much is coming? 6% of 400. How much is coming? Can I tell? This is 24. That is face an accident. Any doubt so far? If 24 number of taxi face an accident belongs to company B, then how many taxi belongs to company B does not face an accident? 400 minus 24. So 400 minus 24 is nothing but 376. No accident. If you have any doubt till now, please ask me here itself. Here itself. Let me scroll down. Yeah, here itself. Here itself, please ask me. Fine. Now, let me give some more information, whatever we have discussed as part of the theoretical classes. As is given in the question saying that 60% of taxi belongs to company A, that is percentage. Now, if I tell me the probability of taxi A belongs to company A, so can I write? Let me use a different color. Okay. Probability of taxi A. So now, out of 1,600 air taxi, right? 600 taxi air belongs to company A only. Now, what is the probability? The probability is nothing but 600 divided by 1,000, nothing but 0.6. Correct? 600 divided by 1,000 probability, right? Probability means you know, right? Now, what is the probability of taxi belongs to company B? 400 divided by 1,000, nothing but 0.4. Yes or no? 0.4. Yes or no? Correct? Any doubt so far? Any doubt so far? Now, tell me, out of 600, 3% face an accident. So 3% means we figure it out, this is 18. Now, if I tell in the probability term, now tell me probability of facing an accident given by that is belongs to company A. That is how much? 3% means 3 divided by 100 is nothing but 0.03. That is the probability. Yes or no? From question I'm deriving guys in a different terminology. If you are able to understand means you are really understand my theoretical concept. Similarly, 6% of the taxi of company B face an accident which is nothing but 24. Now can I write in the probability of facing an accident that belongs to company B? See here, notation C. Here I have written that belongs to company A. Here company B belongs to company B. How much? 6% means can I write 0.06? That is the probability. Yes or no? 0.06 is the probability. Similarly, now it's your turn. Let me ask. Tell me what is the probability of facing no accident, given that this belongs to company A? Can I tell? It is coming 97%, and 97% means in the probability term 0.97. Yes or no? Getting my point. 97% means what? 97 divided by 100 or not? So this is, can I write 0.97? And you know probability is in between range 0 to 1. Yes or no? Just simplest concept, right? Similarly, what is the probability? What is the probability of facing no accident, given that this belongs to company B, is equal to how much? We know in company B, 94% of the taxi belongs to no accident, right? So can I write 0.94? 0.9. This is the extra information that I derived based upon my knowledge from the given problem statement. This is not given, guys. These are the things what are written in the green color. This is not given. I am deriving from the question based upon my knowledge, based upon my understanding. Clear, guys? That's I told you. This is a little bit in depth. And if you understand this, you'll be champion, you'll be master in that. I don't know the previous faculty had gone up to this level or not. Because it's just going through overall theoretical, not going to work out, guys. Okay. I don't want to make information ready. Only just bulk of information store in your head and go to exam. No. You should understand. Clear? Now, come back. This is the extra information I derive fine. That means you are understanding perfect. Now come back to the question. What is the question, guys? It's telling I pick a taxi randomly that face an accident, fantastic, but condition is provided that that taxi belongs to company B only. Now, before going and entering the conditional probability, let's try to understand, find out the taxi that I'm picking from, it belongs to accident. Now, tell me, guys, how many taxi overall? How many taxi face an accident? Now, here I can say taxi face an accident. First one is 18 number of taxi which belongs to company A. Here 24 number of taxi which belongs to company B. So 18 plus 24, these are the number of taxi face an accident. Yes or no? Tell me. Step by step, guys, I'm going. 18 plus 24. If I ask her how, let me explain. Because you can see here 582, no accident, which belongs to company A. Here 376, no accident, means this taxi does not face any accident. This driver, expert driver, no fantastic. This driver are not good, maybe learner or maybe little bit taking some water kind of things. Okay, that's why they are, eating somewhere else. That's why they make an accident. So 18 plus 24 is nothing but how much? Add it off, it's a 242. Now 42 total number of taxi, total number of taxis face an accident. Yes or no? Okay. Now I got it this region. I have to pick a taxi which is from this 42 number. That means this area. 42. So I just let me write down. Total count is, let's say, 42. 42. Okay, fantastic. Now it's telling provided that belongs to company B, because in this 42 also some taxi are there which belongs to company A. company A, that's the 18 taxi. But I have to choose the taxi in such a way that it faces an accident but that belongs to company B. Now tell me how many taxi, okay, how many taxi belongs to company B that face an accident? That's 24. Yes or no? 24. Out of this 42, can I write 24, which is nothing but this one? This belongs to company B. This belongs to company A. So 24 number of taxi belongs to company B, which face an accident. Yes or no? Yes or no, guys? Tell me yes or no. Clear. Now what I'm to find out? Probability of that taxi belongs to company B, provided it faces an accident. Nothing but probability of B means the taxi that belongs to company B is 24. Given that accident, how many total number of taxi face an accident? 42. Now 24 divided by 42, that's how much is coming? 0.57. What is this? This is the probability. If question asking, tell me in percentage, then it will become 57%. Guys, this is the answer that he or she is looking for or interviewer is looking for. If it's asking in terms of probability, you have to give this answer. If it is asking in terms of percentage, you have to give it this answer. Any doubt so far? Any doubt so far, guys? Please let me know. Any doubt so far? Okay. See, I've taken 1000, 1000, this one. You can see total taxi involved in accident. That is 18 plus 24. That is 42. How many taxi belongs to company B which pays an accident? That is 24. So I have to find out probability of a B taxi given that it pays accident. So 24 divided by 42 is nothing but 0.57. Clear? That's how I derive. Because if I show you directly this diagram, you may be confused. What is written? I don't know. That's a step by step I explain in the whiteboard. You feel comfortable. And see, what are things I have explained in the whiteboard derive? Same things also written. Probability A 0.6, probability of B 0.4, probability of accident given A 0.03, probability of accident given B 0.06. Again, other things are not given, but I derive intentionally. Probability of no accident given A, probability of no accident given B. That also I derive in my whiteboard. Extra thing, right? Clear, guys? Any doubt so far? Any doubt so far? So next one is, so this one is completed. Okay, purchase no purchase. Sorry. Okay, purchase no purchase use cases. This is a very simplest, similar to the previous one. Let me explain directly in the my PPT only. Wherever it will be complex, then I'll come back to my whiteboard and I'll explain. Okay, so purchase and no purchase. Okay. So what is the time now? 10:02. Okay, fine. So guys, let's take a small break. Okay. Okay. Another use cases. It is known that 30% of email are spam and 70% are not spam. This is very simplest. Try to compare with the previous one. That's why I'm explaining here. Okay. The word purchase occur. Let me read the question first. In 80% of the spam email, it also occur in 10% of the non-spam email. A new email has the word purchase. What is the probability that it is not spam? Okay, very simple. Try to see. It's telling, let me read one more time. It's known that 30% of the email are spam. So 30% means, for example, I have total 100 emails are there. Out of 100 email is telling 30% of spam. So obviously 30 number of emails are spam. If 30 mails are spam, then obviously 100 minus 30 is equal to 70% of the mail, which is not spam. Is written not spam. NS 70. Fantastic. Now, the word purchase, that is a word called purchase, that occur means present in 80% of the spam mail. Now tell me, how many number of spam mails are there? 30. 18% of 30 is how much? If you calculate, that is coming 24. That means out of 30 spam email, 24 spam email contains the word called purchase. Clear? Then obviously, how many email does not contain the word called purchase? 30 minus 24 is nothing but 6, which does not contain purchase. That's why I've written no purchase. Fantastic. Now, coming to the second part of the question. Uh, okay, it also occur in 10 percentage of the, let me maximize, 10 percentage of the non-spam email. 10 percentage of the not spam email is total no spam email is 70. 10 percentage of the 70 means nothing but 7. Now 7 mail contains the word called purchase. Now tell me, how many email which belongs to non-spam does not contain purchase word? 70 minus 7 is nothing but 63. 63 email does not contain word called purchase which belongs to not spam. Clear? Now my question is, what is the probability that, okay, a new email has the word purchase? Now I receive an email, new email, which contains the word purchase. Fantastic. I want to find out what is the probability that it is not spam. It is not spam means it is, it probability that it is not spam. Not spam means this one. So now I have to find out probability of not spam given by, what is that? I told you that email content purchase. Given that is purchase. Now tell me, how many mail contain the word purchase? Here 24, here 7. Now 24 plus 7 is equal to 31. So the purchase word content number of email is equal to 31. Fantastic. Now out of 31, how many email belongs to no, belongs to not spam which content purchase 37? So it will be 7 divided by 31, nothing but 0.22. That is the probability. If I will convert into percentage, it will be 22 percentage. Clear, guys? Any doubts so far? It's similar to the previous use cases. Very simple. That's why I explained in my PPT itself. Any doubts so far, guys? Please ask. Here it's, yeah. So purchase, no purchase, completed. Very simple. Okay. Now see what is the next one. Okay, this is the same, right? Purchase, no purchase, probability of spam provided, no purchase. Okay. Now, LinkedIn job, no job use cases. Fine. So let me go back to my PPT. Okay. Let me maximize, read the question, then see the answer. It is known that 5% of all LinkedIn user are premium user. 10% of the premium user are actively seeking for new job opportunity. Now only 2% of non-premium user are actively seeking new job opportunity. A random chosen person is not actively seeking new job, what is the probability that he is a premium user? Okay, okay. Now it's obviously a good question. Let me go back to my whiteboard. I'll explain. Obviously, it looks like a little bit complex. If I explain, I will be obviously go over your head. Let me come back to my whiteboard and explain there. Fine. I'll write the question. One second. Nothing to be. Okay. We are trying to find out here. Basically, this is a platform where people are looking for job, right? Naukri, right? Naukri. Similarly, there is another platform called LinkedIn. So people are, trying to make connection with the working professional, trying to approach them. Obviously, recruiter also post if is there any vacancy in their company. So people are trying to apply in their website. Okay, so this is basically job searching platform. Okay, LinkedIn. So here I'm trying to solve a business use cases based upon how many people are actively looking for job, how many people are not actively looking for job, and but they are still present in LinkedIn. Those are things information giving. I'm trying to find out. Let me write down a question. What is giving question? It's telling it's known that 5% of all LinkedIn users are premium users. So I can say 5% people are premium people, premium user. Premium user means they have taken their, let's say, subscription version or something like that. Now tell me, if 5% of people are premium, how many people are not premium? I mean, not taken premium. Obviously, 100 minus 5 is equal to 98 percentage. Can I write no premium or not premium people? Premium users. See, guys, this is not giving the question. You have to derive. That's the beauty. That's what you have to learn from my class, right? In the question, it is giving only 5% people are premium user. So then how many people are not premium? So 100 minus 5 is 95. That you have to derive. This is not given in the question itself. Clear? Now, what is the second? The second problem statement is 10% of the premium user are actively seeking for new job. Now, 10% of the what? 10% of these premium user are actively looking for job. Clear? Similarly, is giving only 2% of non-premium user are actively seeking for job. So 2% of that. Okay, 2% of non-premium user actively looking for job. Actively looking for job. Clear? Now, question is giving. What is question is giving? So problem statement. What the question basically? I choose a random person. A randomly chosen person is not actively seeking for new jobs. So this is the area which is no actively. Oh, sorry. Yeah, not actively looking for job. Okay, this is I have to find out. Probability I have to find out. Condition. What is the condition? Condition. What is the probability that he is a premium user? So condition is he is a premium user. Premium user. This is the question. This is the question you have to figure it out. Clear, guys? Now this is what is written in my PPT in the textual format, in the question format, containing 4 or 5 different lines. If you read it, obviously you will flat. Now this act, the things that you have to learn from this question, how I am deriving such kind of diagram. Then it will be easy for you to put in the formula and get the answer within just fraction of 30 seconds, not even 1 minute. That you have to learn from today's class or from my class. Okay. Now let's try to figure it out. Okay. So it's telling obviously as I told you always the thumb rule or I can say the right set of starting point is whenever it's giving in the percentage, either I have to calculate out of 100 or 1000 or 10,000, whatever maybe based upon my calculation and all. For example, total number of users available LinkedIn, let's say 1000. Okay, so I'm considering total number of users that present in LinkedIn is 1000. Now, out of 1000, guys, what is telling? Try to see. What is telling? 5 percentage are premium user. Now, tell me, 5 percentage of 1000, how much? 5 percentage of 1000, how much? Use your calculator and tell me. Obviously, I should not tell every time you may think that, oh, science is written somewhere else. No. You calculate 5 percentage of 1000, that is coming 50. Okay, that is what? Premium user. Let me write premium. Premium user. Obviously, then how many percentage is non-premium? 95. But I can say 1000 minus 50. Can I tell 95? 950 are not premium. Not premium. Yes or no? Now, again, let's come back to the premium. We'll subdivide, then we'll go to the non-premium. Okay. What is telling? The concept is same. See, I'm trying to solve in the same fashion. If you understand one problem statement, rest of the things are just same. Now, it's telling 10 percentage of the premium user are actively looking for jobs. Now tell me, 10 percentage of 50, how much? 10 percentage of 50 is nothing but 5. They are actively looking for job. Actively looking for job. So I'm just simply write actively job. Okay, then 50 minus 5, how much? 50 minus 5, 45. They are not looking for job. Just in short, I'm writing no job. Okay, no job. Not looking for job, or I'm writing simply no job. Okay. Similarly, come to the non-premium part. Come to non-premium part. Very simple. Now you're feeling comfortable. See, in front of you only I'm deriving this diagram. Okay. And at the end, if you observe the PPT, it will be same as whatever I am writing in the whiteboard. Don't worry, I'll share this whiteboard. Okay, in my Telegram channel. Okay. I hope all of you join my Telegram channel. Right? Yeah. So now tell me, what is the question? 2 percentage of the people of this non-premium actively looking for job. Now tell me, 2% percentage of 950 is how much? That is 90. You calculate 90. Then 950 minus 19, how much? 950 minus 19, it will come 931. Those people are not looking for job. Can I write? So here they are actively looking for job. In short, I'm writing job. Here they are not looking for job, so no job. No job. Clear? Actually, for us, this information is sufficient. But let me, I'm very curious. I am to go a little bit in depth. I am to implement what are the theoretical concepts we have learned in our class that I am to implement. Now tell me, so extra thing I'm. What is the probability of premium user? Now that is nothing but 50 divided by 1000. That is nothing but 0.05. Yes or no? 0.05. Yes or no? Similarly, what is the probability of, sorry, not A, this is premium, premium, PRE, premium. Okay. What is the probability of not premium or no premium? No premium is equal to 950 divided by 1000 is nothing but 0.95. Yes or no? Guys, yes or no? These are the things I'm deriving because somebody may ask in the interview itself, of course, by itself or maybe semester exam itself. That's why I'm going little bit one step ahead, deeper. Okay, but for us, these are the information not required to calculate this. I mean, what is the probability of not actually looking for job, having given premium user? These are the information not required. But why I'm writing, if somebody asks, okay, tell me, what is the probability of non-premium user? 0.95. What is the probability of premium user? 0.05. Now they will ask, okay, tell me, what is the probability of actively looking for job provided this is premium? premium. Now this will be 5 divided by 50. How much that will come? That is come around 0.10. Similarly, what is the probability of not looking for job, not looking for job, provided this is a premium? Premium. Guys, are you able to understand up to what depth I am going? So this will be 0.9. 0.9. How come 0.9? Very simple, right? 45 divided by 50. 9 by 10 is nothing but 0.9. Yes or no? Clear? That's why 0.9. Here 5 divided by 50. That's why 0.10. Similarly, what is the probability of job given not premium? Previously premium, this is not premium. Not premium. How much? 19 divided by 950. How much it will come? 19 divided by 950, it is coming around 0.02. Use the calculator, you'll get to 0.0. Yes or no? Okay. Similarly, probability of no job, no job, given not premium, not premium. How much it will come? 931 divided by 950. How much? Whatever will come, that will be the value. Okay, fine. Okay, let it be. Stop it. Now come back to our problem statement. What exactly is asking? Not actively looking for job. Now tell me, guys, how many persons are there who are not actively looking for job? Now this is actively looking for job, not looking for job. So this one 45. Then this is looking for job 931. Oh, okay. These are the people who are not actively looking for job. Now tell me how much that one? 45 plus 931. These are the people who are not actively looking for job. Guys, clear? Any doubt so far? Any doubt so far? Now, out of this, guys, out of this, obviously, so 45 belongs to premium. Let me write down premium. This is not premium. Premium. What is the conditional probability is giving? Premium user. That means find the probability of premium user given that not looking for job, no job, or not job, or no job, no job. So no job I find out, or not looking for job is nothing but 45 plus 931, whatever will come. Now premium user, out of this, how many premium user belongs to premium? 45. So that is 45 divided by this one. How much, guys? Could you please calculate? Use your calculator, tell me. Use your calculator and tell me. 45 divided by 45 plus 931 is coming around, I hope, 0.04. Use your calculator and let me know fast. 0.046 if I'm not wrong. This is the probability and this is the answer what they are looking for. If they will ask, so tell me the percentage. Very simple, sir. If I want the percentage, then it will be percentage is equal to how much? 4.6%. Clear, guys? Any doubts so far? Any doubts so far? Let me see your. So without wasting time, let me complete as soon as possible. Yeah. So now the e-commerce. E-commerce, then another two. Okay. So e-commerce website are use cases. So these three I will directly explain in the PPT so that we can save the time. Now by this time I think you are feeling comfortable. Same way how I am designing the diagram, how I am deriving the diagram. Okay, fine. So e-commerce website are use cases. E-commerce website ads use cases. This is very, very interesting, guys. These are all real-time use cases because see, while teaching, we cannot take directly name. That's why I'm using company a company. Because frankly speaking, let me give a hint between the use case between the Ola and Uber. I'm not able to recognize because I indirectly tell, right? Two company, big company, they're providing your tax services. Now tell me, tax services means obviously two company exist in the market, in the India market, Ola and Uber, right? So you have to think. But generally, while teaching, we cannot take directly name, right? That's why. Even e-commerce, obviously you will get to know that. Maybe think about maybe Myntra, maybe Amazon, maybe Flipkart, whatever maybe. Okay, that I will explain. Fine. So let me go back to my PPT again. Okay. Now see guys, let me maximize read the question, then we'll try to solve. Okay. An e-commerce website shows two types of ad, type A and type B ad. Whatever ad. Let's say one ad is related to t-shirt, another ad is related to let's say uh, any mobile phone, mobile devices. Now, 60% of the visitor see type A ads. For example, 60% of the people are looking let's say mobile ads, and 40% of the visitors see type B ads, means related to t-shirt and all. Okay, the click-through rate means generally whenever you are seeing the ad, think about real time. Let's say you are, running a video or watching a video in the YouTube. You might have seen there is some ads is showing in the below area or in the right hand side area. If you like that, you click on that. Then it will navigate to that particular website. Then obviously you will go for purchasing or not purchasing. That depends upon you. That is called click-through rate. In short, I'm writing CTR, click-through rate. Okay, of type A ad is 5%. It means 5% of the people out of that 40 percentage who are seeing, out of the 60% who are seeing the ads, they are clicking on that. Fantastic. While the click-through rate of type B ads is 3%. It means 40% of people are seeing type B ads. Out of that, only 3% click on that ads. Now, the question is, a visitor to the website does not click the ad. Okay, what is the probability that he saw a type A R? Clear? Now try to solve. Let's see. First, assume, as I told you, let's say total number of people, or total number of, think about the hours. Okay, total number of people, think about the people, is 1000. Out of 1000, it's written 60 percentage of the visitors see type AR. 60 percentage of 1000, nothing but 600. 600 people see type AR. Fantastic. Now 1000 minus 600 is nothing but 400. 400 people look for type BR. Is written type A and type B. Correct? Till this point, guys, clear. Don't look into this right hand side all at a time. You'll be confused. Step by step. Till this point, any doubt? 1600, 400. No doubt, clear? Very simple. Now, come to type AR. Now, what is the second part is telling? Second part is telling, the click-through rate of type AR is 5%. Means 5% of 600 people click on that ad. Now tell me, 5% of 600 means how much? It's 30. Now 30 people click on that ad. That is click through rate, everything. Now how many people does not click on the ad? 600 minus 30, that is 570. That's all. Not click through ad. Fantastic. Now similarly, coming to type B ad. While the click through rate of type B is 3%. Now 3% of 400 is how much? 12. 12 people out of 400 people click on the ad. Now tell me how many people does not click the ad? 400 minus 12 is nothing but 388. Does not click the ad which belongs to part B. That's all. Okay, I'm not writing here like probability of A, probability of B, right, by this time. Here probability of A is nothing but 600 divided by 1000, nothing but 0.6. Here 0.4. Then probability of, you can find out, right? I'm not wasting my time. Fine. Now, question. A visitor of the website does not click the ad. Now tell me, how many people does not click the ad total? Here, 570, not click through ad. Here, 388, not click through ad. So I've written here, number of visitors does not click the ad. 570 plus 388. Okay, whatever it will come. Now, out of this, how many people is telling? What is the probability that he saw the type A ad? Now, type A ad, how much number of people see type A ad is equal to? I mean, see the type A ad is equal to 570, but does not click. That is 570. Now, it's asking probability of the person see type A ad but does not click the R is nothing but 570 divided by 570 plus 388. If you calculate, it's coming around 0.59. That is the probability. If I will convert into percentage, then it will come 59 percentage. Guys, any doubt so far? Any doubt so far? Please let me know. Any doubt so far? Very, very interesting, guys. Okay, if no doubt, let me go to the next PPT. Yeah, this is very, very interesting. Suppose it's a color blindness example. Generally, it's a medical domain. We use such type of problem statement to find out the answer. Suppose 5% of the men and 0.25 percentage of the women are color blind. Color blind means they are visually impaired person, they are not able to see properly. Okay, a random color blind person is chosen. What is the probability of this person being male? Assuming that there are equal number of men and women. If equal number of men and women, guys, think. Just I'm just explaining. Let's say 1,000 total population are there. It's telling equal number of men and women. Can I say 500 people belongs to male, 500 people belongs to women? Clear. First step clear. Okay. Now it's telling. Suppose 5% of the men, 5% of 500, how much? Whatever will come. Okay, that many people. And 0.25 percentage of the women, 0.25% of 500 is nothing but color blind. Fantastic. Now figure it out, the diagram and all. Here also I have written here. Okay, 50 percentage, I think in the next diagram, yeah, you can see. I have taken, let's say, 20K, 20,000 population. 50-50 means 10K belongs to male, 10K belongs to female. Fantastic. Now, in this 10K, it's telling 5% of people belongs to color blind. So in short, I'm writing CP, color blind. 5% of 10,000 means 500 people. Now, how many people are not color blind? Which are men? That is 10,000 minus 500, 9,500, not color blind, NCB. Fantastic. Now, 0.25 percentage of female, okay, are colorblind. So 0.25 percentage means out of 10,000 nothing but 25. 25% are colorblind. So 10,000 minus 25 is nothing but 9,975 is not colorblind. Fantastic. Now my question is, I pick a person randomly who is colorblind and tell me what the probability that is male. Now colorblind is total how much? 500 plus 25 is 525 below. Now, out of this, how many belongs to men? Men is 500. So 500 divided by 500 plus 25. Whatever the answer will come, that's the answer. Clear, guys? Any doubt so far? Any doubt so far? This is very simple. Any doubt so far? Please let me. Let me see your chat box. Okay, so this one is completed successfully. Now color blind completed. Now the last use cases, that is children example. Then with this I can say almost how much? One, two, three, four, five, six, seven. Seven different use cases. Okay, seven use cases. Business use cases. This is not normal use cases. Okay, all are business case studies. We have completed successfully. Okay, similarly in the part one also I have covered almost 6 to 7, almost total 12 to 15 use cases I have solved. Okay, with this you will be master, champion in the conventional probability. That is my intention. Okay, I'm not just covering the theoretical concept and all. Okay, fine. Now children example. Now come back, children example. But the number I forget. Is it 12 or 13? That's all of you clear about color blindness. I don't need to explain in the whiteboard, I hope. Right? You want me to explain in the whiteboard? Okay, guys, let's have a look. A family has two children. At least one of them is a girl. What is the probability that both are girl? Okay. A family has two children. So two children means you are telling maybe the first one will be boy, second one will be maybe boy. I mean, what is the sample? I mean, a possibility are there. The elder one may be boy, younger one may be girl. Elder one may be girl, younger one may be boy, or maybe both are girl. That is only four combination will come. Correct? If a person or family having two kids, right? Now the question is, at least one of them is a girl. Okay, fantastic. Now, what is the probability that both are girl? Now, see how I'm trying to solve. While you're looking or reading the question, it looks little bit complex, not that much straightforward. But try to see how step by step I'm splitting this question. I'm trying to solve the approach. Try to learn. That is very very important. You should not learn. Okay, solve the problem. We got the answer. No, that should not be your intention. The approach to solve a problem, how I'm splitting a complex problem into simple part, then I'm combining and getting the final answer. That is very very important, that you have to learn from today's class. Clear? Now see, as I told you, sample, the possibility may be these four cases, maybe two boy, two girl, or one boy one girl. That may be again boy first, then girl first, or boy. That may be four possibility are there. Fantastic. Now I'm taking two conditions. What is the condition? First condition is both are girl. Okay. B is at least one girl. Why? Because in my question is written clearly. See, read the question carefully. At least one of them is a girl. What do you mean by at least one of the girl? Either one girl, then boy, or boy, then girl, or maybe two girl. Getting my point? But out of this sample, for sample, it's telling accepted criteria is only three because at least one girl. Why not sir boy? If I take boy, where two kids are there, both are boy, then here there is no chance of making one girl, at least one girl, because both are boy. But except this case, boy, if I consider any other cases here, at least one girl is present. Here, see, one girl is present. Here, one girl is present. Here, obviously, two girls is present. At least means one girl is present by default, right? Now, see how I'm solving. Now, I'm taking two conditions. Age, both are girl. That means this condition, GG, both are girl. B is at least one girl. That means these two conditions. Either BG, boys girl, or girl boys. Fantastic. Now, try to find out what is the probability of A. So, what is A? I have defined both are girl. Now, tell me, what is the probability that both are girl? Now, I told you we have total four possibility at that combination. Out of this four possibility, a combination, tell me in how many ways only two girls are present. I mean both are girls. Only one. That means I can I say one by four is a probability. Means out of four, only one possibility is there where both girl will come. Here there is one by four. Now, what is the probability of B? Tell me what is B first. Now B is nothing but at least one girl will be there. Now out of this four possibility, at least one girl present in three different way. Either boys girl or girl boys or girl girl. Now can I write 3 by 4? So 3 by 4 is the probability. Clear? Now, what is P probability of A intersection B? A intersection B is A is nothing but girl. B is nothing but boys girls boys, and girls. Now if these are two different set, What is the common one? Common is nothing but gal because gal present in both the cases, either P of A or P of B. So that is 1 by 4. By probability nothing but 1 by 4. Now what is the question? Question is given what is the probability that both are gal? So both are gal means A, probability of A, provided at least one of them is a gal. That is probability of B. So probability find the probability of A given B is nothing but according to the formula. First initial time in my today's class I have explained. P of A intersection B divided by P of B. Nothing but 1 by 4 divided by 4 is nothing but 1 by 3. That means C also alternative way. So this is the formula step. I am explaining 1 by 4. Can I use directly Bayes theorem conditional probability and in one line I can find out how? Probability of both gal, at least one gal. So here four possibility are there. Gal, gals boys, boys boys. Tell me out of this, at least one girls means only three condition I will accept these three. Boys I cannot accept. Now out of these three, how many times both gal will come? Only one time. So out of three, one time. So 1 by 3. Can I write? So new conditional sample space, that is 1 by 3. So if you know how what is the conditional probability concept, see within a one line I am getting the answer. But if you don't know, okay, go through the formula, go step by step, find P of A, P of B, P of A intersection B, put in the formula and get the answer. Like 4 5 lines you have to write and you have to get the answer. But here if I know the concept, I understand how it works. Simply, I am getting because I know out of these four, three cases where at least one gal is present. That is three. Out of these three, how many cases both gal will come? Only one case. So 1 by 3. That's all. That is the answer. Simply one line. I am completing my answer. Clear, guys? Any doubt so far? Any doubt so? Quick introduction to Bernoulli Naive Bayes. Generally, guys, in short, I'm just telling. Bernoulli Naive Bayes we use basically a binary format where generally the two output 0 or 1 will come. I'll tell you the big difference between the one of other hand multinomial Naive Bayes also present. There are two things. One is Bernoulli Naive Bayes, one is multinomial Naive Bayes. I have a very clear cut difference also. What is the difference that I'll explain within just 2 minutes. Okay. It's worth nothing that the details explained of the Bernoulli Naive Bayes is not covered in this course, but it's available on the platform reference. In the platform of the platform is present, but fine. Bernoulli Naive Bayes is a variant of simply Naive Bayes classifier designed for binary, that is 0 or 1 data. It's commonly used for text classification, especially for text like spam detection. Okay, spam detection where the presence or absence of a word matters a lot. Okay, presence or absence of the word matters a lot. Now, what is the key difference? The binary feature, each feature is either 0. If present, that is 1. If not present, that is 0. Conventional probability computes probability based on whether a feature words appear in the document or not. Okay. Now, Laplace smoothing prevent zero probability issue by adding a small constant. Now, suitable for the text data often applied in the bag upward tape idea. So, bag upward and tape idea, these are the advanced technology that you learn as part of deep learning. Now, you are learning machine learning, right? When you go to advanced topic, that is a part of deep learning. In deep learning, there is a particular concept called NLP, natural language processing. As part of NLP, you will learn what is DAG of one, what is TF-IDF. TF-IDF stands for term frequency and inverse document frequency. Okay, that is not required for as of now. But so this is the formula. Probability of C given X is directly proportional to probability of C into summation starting from I is equal to 1 to n probability of X given C. This is what we have already derived in our initial classes of students. Okay, now we can see. For example, taking three, four class, words, free, win, offer, hello. If it is present, three word is present, then I'm putting one, spam email. Win present, yes. Offer present, yes. Hello not present, then zero. Hello is present in another mail, that's a half mail. So here I'm putting one. So as I told you, if the particular word, let's say if a new email contains free and win, Bernoulli Naive check if those words present or not. If present, put one. If not present, put zero. Okay, let's talk about the Bernoulli theorem. But what's about? But what is the key takeaway that I have told you, right? Best for binary feature, work well in a bag of word and all. Often uses spam detection, sentiment analysis, and text classification. Does not consider word frequency. Okay, now see what is key difference between Bernoulli Naive and multinomial Naive. This Bernoulli Naive talk about a particular word is present or not. That is binary. If present, yes. Not present, zero. Check if a word is present or absent in your document. That's all. But coming to multinomial, is talking about the count. If that particular word is present, now tell me how many times it's present. 3 times, 5 times, 10 times, 50 times, or 100 times. Uses the frequency of the word in the document. That means count number of times. Okay. Focus emphasizes word presence rather than frequency. It just emphasizes on word present. Present or not. If present, tell me yes. If not present, tell me zero. But it talks about emphasizing word frequency, means count how many times he present. It's not worry about whether present or not. If present, how many times he present. Okay. Now, data representation, how we'll get to know presence or not binary bag of one. That is, I told you, part of the NLP, natural language processing, and technology. Okay, don't think about that. Now, this thing we can find out by using turn frequency and inverse document frequency, that is TF and IDF. Okay. Now, handling of missing word penalizes the document missing important word. Why? Because missing is when, for example, word is present. If my model predict not present, then say wrong actually, because not present means giving output as zero. But as it present, I'm expecting the output to come as one. But here, less sensitive for missing the word since frequency does not matter. Frequency matters a lot. Okay. Best use cases: short test, binary classification, spam detection, sentiment analysis, and all. But here, longer test, document classification, topic modeling, and all. Okay. These are the different use cases. Now, Bernoulli Naive. For example, win offer free. 3 words I'm talking. Check if the word present or not. If present, put one. If not present, put zero. Multinomial neighbors, for example, word called win appears how many times? Okay, 2 times. Offer appears 3 times. Free, let's say, appears 7 times or 10 times or 1,000 times. So count matter. In multinomial navigars, count matter. In monomial navigars, only presence matter. Whether present or not. That's all, guys. Okay. So the key difference I'm giving where to use. If it is a short test, you have to use a Bernoulli navigars like spam detection. Okay. Sentiment analysis. If it is longer document like new categorization, topic classification, then you have to use multinomial navigars. If binary feature, presence or absent, Bernoulli. If frequency based, that is multinomial. That's all about the difference between the bets and all. Obviously, this thing I have already shown you. Clear, guys? Any doubts so far?